Hello everyone, welcome to another technical deep dive. My name is Cody, and in this episode we're going to provide a comprehensive overview of trackables in the DeepHub. We'll explain what they are, why they're such a fundamental component of the DeepHub, and how they may be used to spark a diverse array of use cases and applications. As the name suggests, a trackable is a digital representation of a physical object that may be tracked with location technologies. This could include a truck, a forklift, a parcel, a worker, etc. Recall from a previous episode that the low-level positioning hardware of locating systems, such as a BLE tag or a GNSS receiver, are represented in the DeepHub as location providers. These are the devices that generate location updates. Through the DeepHub, you can associate multiple location providers to individual trackables, allowing objects to be tracked across any real-time locating system or proximity system from any vendor. This enables you to strategically harness the strengths of each technology, ensuring your solution is extremely robust, flexible, and precise. For example, consider a modern warehouse with a fleet of forklifts, where the efficiency of each forklift is integral to the overall success of the facility. Having the ability to monitor the movement and location of each forklift in real time would enable the facility manager to identify bottlenecks, streamline operations, and increase output. Seamlessly tracking the forklifts across multiple locating technologies would make this a reality. To achieve this with the DeepHub, each forklift would be represented as a trackable and would be affixed with two location providers, one for the GNSS receiver for outdoor tracking and one for the ultra-wideband tag for indoor tracking. While traveling outside the facility, the forklifts would be tracked through GNSS, and while traveling inside the facility, they would be tracked with ultra-wideband. As each location provider generates location updates, the location of each trackable would be updated in the DeepHub as well. The movement of trackables, made possible by the location updates of their associated location providers, are called trackable motions. We will now explore how to manage trackables through the DeepHub UI, the REST API, and the WebSocket API. You will first need the DeepHub installed. There's a link in the video description down below with a step-by-step guide on how to do this. Here in the admin UI, to create a new trackable, first click Create Entities, and then Trackable. From here, a unique ID will be automatically generated, and you'll have the ability to add several optional properties, including a descriptive name, the radius in meters, timeout, tolerance, and delay properties. These allow for much greater flexibility in the way collision and fence events are generated and utilized for advanced location-based use cases. For now, we will not change these properties, but we'll explore them in a future episode of this series. Subscribe to our channel so you don't miss it. The extrusion or height of the trackable in meters, and the location providers associated with this trackable. Recall that multiple location providers can be linked to a single trackable, regardless of the locating technology or the vendor. All the location providers in my DeepHub instance are listed here, and if I start typing, I can filter for specific ones as well. Toggling on this option will ensure that as soon as this trackable is created, the most recent location from its associated location providers will be reprocessed. This may be necessary for various scenarios. For example, if one of the trackable's associated location providers is currently within a fence, a corresponding fence event would need to be generated. Forcing a location update in this case would ensure the fence event is generated. For more details on these properties, refer to our documentation. There's a link in the video description down below. There's a few options that allow you to fine-tune trackables even further. The first is the ability to configure how collision events are handled for a specific trackable. There are three options. The first is the default behavior that is set system-wide for all trackables. This is set to true by default, ensuring that this trackable may generate collision events. The second option ensures that this trackable does not generate collision events. Finally, the last option ensures this trackable generates collision events. The trackable parent property allows you to create a trackable hierarchy, thereby linking trackables together in a parent-child relationship. In this way, location information from a parent trackable may be propagated down to its associated child trackables. This can greatly simplify integration efforts in various scenarios, as it eliminates the need to attach location providers to every single trackable in your system. We will also cover this topic in more detail in a future episode, so stay tuned for that. Custom properties can be added that are specific to the application or solution using the DeepHub or the physical object that the trackable represents. For example, if a trackable is created to represent a forklift, custom properties could be added that identify the forklift's serial number, load capacity, lift height, etc. Finally, you may use the rule engine to assign rules to trackables. These dictate the prioritization of location providers in relation to trackables, ensuring the most accurate and appropriate location update is used at any given time and in any scenario. We have an episode dedicated to the rule engine, so check that out for more details. Once I'm done, I'll click Save. If you need to modify a trackable, first click Trackables at the top of the screen to pull up a list of all trackables. Find the correct one and then click Edit. Alternatively, you can search for a trackable using its name, ID, or even one of its custom properties. From here, you can modify its properties or delete the trackable entirely. When my edits are done, I'll click Update. Once your trackables are created and configured, they will be visually displayed on the map, and you will be able to see them moving as their locations are updated by their location providers. They are represented with a red icon. If you set a value for the radius property, this will be reflected on the map with a red octagon encompassing the trackable. Similarly, if a geometry is defined for the trackable, this will be shown in red around the trackable. The latter will be discussed in more detail in the next section. The REST API has several endpoints to manage trackables, allowing you to create, update, and delete trackables, fetch information attributed to specific trackables, and update the global settings for the rule engine. We'll highlight a few of them here. The post trackables endpoint may be used to create a new trackable. A unique ID may be provided, otherwise one will be automatically generated. You must specify the trackable type, either omlox or virtual. A trackable of type omlox can detect which location providers are available to it and independently assigns them for location tracking. For example, this could be a device that has embedded location technology hardware within it, such as an ultra-wideband chip. Any other trackable object would be of type virtual. When creating a trackable in the UI, like we did earlier, the default type is also virtual. Aside from the properties that were already discussed, you may also provide a geometry for the trackable and its corresponding coordinates. I'll set the force location update parameter to true so that a trackable motion is generated for this new trackable as soon as it's created. A 201 response confirms the request was successful. We can see in the UI that the trackable was created and its geometry is visualized in red. There are several endpoints that may be used to query for helpful information. Get trackable summary returns a summary of all trackables and their properties. Get trackables trackable ID returns a summary of a specific trackable with the provided ID. Additionally, the API may be used to return the global rule set defined through the rule engine, all fences a trackable is currently within, the location of a specific trackable, the motion of a specific trackable, the location providers associated with the trackable, and sensor data from the trackable's location providers. The trackable that was just created is linked to a location provider that has sensor data. To fetch this, I'll use the get trackables trackable ID sensors endpoint and provide the trackable's ID. To update a specific trackable, you may use the put trackables trackable ID or the patch trackables trackable ID endpoints. The former replaces the entire resource with what's provided in the request. The latter performs a partial update with just the properties that need to change. In this way, the patch request provides a convenient method of updating one or more properties without having to include all properties in the request, even those that are not being modified. In this case, I'll use the put endpoint to completely update this specific trackable by adding a geometry and removing the radius. A 200 OK response indicates the request was successful, and as soon as the trackable moves in the UI, we will see the updated geometry. Finally, you may use delete trackables to delete all trackables, or delete trackables trackable ID to delete a specific trackable. I'll use the latter to delete this trackable. A 204 response confirms the request was successful, and we can see in the UI that the trackable has been deleted. Using the WebSocket API, a WebSocket connection can be established with the DeepHub to subscribe to collision events and trackable motions. Through this connection, your application can receive real-time collision events and trackable motions and harness them however you see fit. To demonstrate this, I'll subscribe to the trackable motions topic and filter with a specific trackable ID. As this trackable moves, corresponding WebSocket messages and their payloads are received. The message payload contains critical information, such as the trackable's location, the ID of the location provider that caused the trackable motion, the timestamp of the movement speed of the trackable, and the updated coordinates of its geometry. We'll cover WebSockets in much more detail in a future episode, so stay tuned for that. As the administrator of your DeepHub instance, you now have everything set up in relation to your trackables. We recommend exporting all the entities in your DeepHub instance to back up your data. This will ensure that, if needed, you can quickly set up your system again. This can be done directly within the UI by going to Settings, and then Import and Export. Select the necessary entities, and then click Export. In this episode, we provided a comprehensive overview of trackables in the DeepHub. We outlined how they may be used with the UI, the REST API, and the WebSocket API to enable greater flexibility and precision for advanced location-based services and applications. However, this was merely the tip of the iceberg. We encourage you to explore trackables for yourself and leave any comments or questions down below. Thank you for watching. Please like and share this video if you found it helpful, and subscribe to our channel for more future DeepHub content.